Okay, hi, I'm Itai. I'm one of the engineers from Chroma. Anyone heard or used Chroma before? Nice. Um, so yeah, I tried to like not make this a sales pitch for Chroma. By the way, I've never spoken in front of a crowd like this before, so you know, excuse me. Um, So maybe you've heard of ChromaDB, the vector database. It's an open source vector DB that grew into like really a search system for any kind of AI workloads. We have a ton of stars on GitHub and downloads, and we also have a hosted service called Chroma Cloud. I've met a lot of European folks a few minutes before this, and we are now also available in Europe. So check that out. We also, as of last month, have models. So we trained Context-1. It's a 20B open source model that outperforms Opus at agentic search that I will demo later today. And we also do a lot of research on search and AI. Maybe anyone heard about context rot? So yeah, that's a sort of seminal report that we put together last year, and we also love to talk about context engineering. So zooming out, traditional software, the computer is great at processing structured information using effective procedures, algorithm. The AI computer is great at processing unstructured information and simulate any intuitive procedure, which, if you think about it, that's what reasoning is. So at Chroma, we think that, AI is really context plus that reasoning. So, people use Chroma to store and read context for AI, and then they use, whatever model they like for reasoning. I thought that's like an interesting report that most of the ChatGPT queries are asking centric, less than doing centric. Mostly with AI, we're trying to find information before we can do anything with it. This report also shows that 30% of knowledge workers' time is spent on searching, right? Before we do something useful, we kind of like need to gather a lot of information to be able to do it in the first place. And that's what really we're doing when we're building agents, right? Agents have some context, so that is like the information we gather to let them do what we want them to do. They both need to read that context, and that may be a huge amount of information, and they also write that context back, right? Like if the agentic process is producing artifacts or need to modify the environment of the agent, that is the process that writes the context back for the next iterations. And dealing with this context is really hard. So if you heard about context rot, that is the phenomenon of that everyone experiences, even if you just use ChatGPT or Cloud Code. Like the longer the session is, the worse results you get, and even I think official docs tell you like, oh, if your Cloud Code session goes on for too long, just like restart or reset the context or whatever. And so what goes into that context? Like a lot of things, right? All the system prompts, the environment state, the tools, the tool results, the memory systems, the user prompts. There's a lot of things that sort of like you need to parse through when you write your agents to be able to send the correct information to the model for reasoning. And most AI fillers today are really not reasoning failures. Like the models are excellent at reasoning, but they're really about the context or the information that we give them. So it's not only about cost and trying to save tokens on the amount of information you send, but it's also how you structure that information and were you able to maximize the output from the model given the tokens you send it in your context. So, if we think about the spectrum of context and the reasoning that we can do, we can either send, a little information, a lot of information, and we can either ask the model to do simple things or very complicated things. So, for example, a little info can be a single 10-page PDF or a single repo. A lot of info can be like the kind of information we really want to use when we're building serious AI applications. So, like the Claude bots, right? Like all your personal information, all of your company's information, all of the world's information. So a simple query can be, what is the capital of Finland? And a complex query can be, what supplements should I take? How has our positioning on enterprise versus self-serve, blah, blah, blah. So, and we kind of like want to live in this space to do useful things, right? Like be able to solve processes that require multi-hop information gathering and reasoning. And yeah, the goal is to really build, I guess you can go back in Figma. Okay, whatever. So the goal is to build applications that can really span the entire spectrum, right? Like be able to answer things quickly for simple queries, but also answer really complicated queries that require a lot of context. So how do we solve that problem? We can just use more tokens, right? So every time we're trying to build context, we can turn that process in itself into an agentic search process, right? Instead of just picking and choosing by some deterministic mechanism what goes into the context, we tell a sub-search agent, go and figure out everything that should go into the context in this turn. And that's also true for the writing process, right? If the agent decides, oh, I recognize this user preference from the conversation, then we want to figure out what is the correct place in the agent's memory or environment state to persist that sort of insight from the reasoning model. So yeah, pheromone tokens are the problem, right? Turn the search itself into an agentic sub-process. So what is agentic search? Anyone familiar with agentic search? Okay, so that is the process of basically giving a model some sort of search tool. So for example, the ability to search over a Chroma collection, over your file system, over whatever, and repeatedly gather more and more information until it decides that it has enough results to provide the answer. So if you used, okay, maybe I'll get more hands. Who used Claude Code or Codex? Yeah. So you probably noticed that at every turn it greps a lot, right? Like it issues like seds or whatever to sort of like look for information in your file system to be able to answer the question. So that is what is also known as agentic search. So if before we had this like read and write path for the context, we can basically solve the challenge of building the correct context by delegating that to another agentic process, which is agentic search. So that process in itself can be very expensive, right? It's like more tokens to spend on just like building context for the parent task. So this past March, which is, I guess, a month or so ago, we published Context-1, which is a model that basically allows you to do we trained it to be able to do agentic search over a Chroma collection. So we took, ChatGPT OSS, GPT OSS 20 billion, and we taught it how to use search tools over a Chroma collection to basically bake that agentic process into the model itself. What does that mean? It means that if traditionally you would have basically a loop calling Cloud or GPT with that search tool, and every time send that information to the model until it decides, okay, I have the answer, now go ahead, we're able to sort of delegate that process entirely to this open source model. So it's a lot faster, and it's also a lot cheaper. You don't have to pay tokens to a big, powerful model. And you can read the report. It's on our website. It performs very, very well. And there's a little animation here that I hope will work, comparing Opus to our Context-1. So we're able to process way more tokens per second and for way less dollars. So this is supposed to, sort of demonstrate. This is Context-1, so you can see it goes through way more tokens to fill up. Okay, we're able to see this? Did it work? Okay, whatever. I'll show you a real demo. So I have here, this is the dashboard for Chroma Cloud. And I have here a collection where I indexed all of our Slack messages. So I can ask, what are the Chroma team's favorite lunch spots? So, and again here, we're basically delegating the search task to Context-1 to sort of like search through this collection, and then just one LLM call at the end to sort of take the answers and compile a result. So it correctly said that we like to go to Altepa, Kitava, Shake Shack, Stable Cafe, Gus Market, which are basically all places that are around our office. And it was pretty fast. It took like about 19 seconds for the actual searches and then one more call to an LLM. So if I do the same thing but with a traditional agentic search process, so there's a small Python script over here where maybe you've written something like that yourself before. So while loop, call a model with a search tool and keep going. There's like a prompt over here you can see. You are a research assistant. You are going to perform hybrid search over the collection. You called multiple times until you have enough information, blah, blah, blah. So if I already made the command. So UV run this like Python script. And you will see that it basically does the same process that I described, agentic search, but it's going to be much, much slower because every time we need to call Claude or GPT or whatever, and it's also going to be quite expensive if you think about scaling this to like a real search task. It's still going, so I paid $0.1 for this, spent a bunch of tokens, and it took 25 seconds. So yeah, we really believe at Chroma that open source models, or I guess small models that are very good at a specific task, are the future. A search model is something that everyone will need, and that was Context-1. It's still in I guess research preview for select customers. If you want to get on it, the first step is to get your data on Chroma Cloud. Like, we're not doing things for free, but at least things of that shape. And yeah, well, that's all for me.
Hey, thanks so much for this talk.
You're welcome.
I wonder if you have any multilingual results on benchmarks for searching, so other languages than English, and whether you see like a big drop there, or whether it kind of stays stable, and what kind of future plans you might have for that.
Sorry, you're asking about benchmarks on this
like multilingual?
Oh, multilingual benchmark. I actually don't know. That's a good question. Yeah, I don't know. That's my honest question.
Cool. Maybe we can find out later.
Yeah.
Thanks, though.
I think, yeah, we dealt with English mostly. Yeah, this model was trained using, like, I don't know, huge data sets that I'm pretty sure are mostly in English. So like SEC data, the Epstein files, yeah.
Okay, for sure, for sure. Looking forward for the next.
All right, any other questions for Itai? Right here.
Hi, thanks for the talk. I don't know if I missed it, but just interested in the technical details. You mentioned that maybe outperforms like a search with Claude. Is the key to the outperformance, is it looking over more documents, or is it when you trained it, it has much more documents to learn over?
Yeah, so the research report is on our website. It was basically trained to, be very good at using all of the search capabilities that Chroma has. So there's a search over using dense embeddings, sparse embeddings, hybrid search, grep style searching. The model also is very good at editing its own context. So instead of like keeping, huge parts of information in memory, sort of like can decide, okay, this is no longer relevant. We already like exhausted this search path. Like let's get rid of it to sort of like be token efficient, and all kinds of like other tricks, sort of to like optimize the context for a specific search task. And it was trained on sort of also like all kinds of search tasks, like needle in a haystack, just like find something in a corpus of information. Also a lot of like multi-hop searches, so using benchmarks like Browse.com Plus, if you're familiar with it. So sort of where the answer is not necessarily going to be discoverable by getting I don't know, n number of documents, but really one document reveals the need to perform another search that will reveal more documents that will bring you to another search until you get the answer. So it was trained using these kinds of complicated search tasks. Yeah.
Cool. Thank you.
This row is like full of questions. Yeah.
Thank you. Yeah, I wanted to understand more around the complexity of the queries that can be searched in an enterprise context. As you said, multi-hop reasoning, right? So, if, like, how straightforward these answers are? Are these coming from a one-on-one conversation, or it's a group, let's say, talking to each other for multiple days, things going to and fro, and then more teams coming in?
Yeah. So that's why I showed this Slack example, because if you think about like Slack messages, they're sort of like one messages can be like, where are we going to get lunch? The next message can be like a bunch of options. And there isn't like a single query that will give you all that information. The model sort of needs to know, oh, let me look for all like lunch mentions. Then let me look at surrounding information. Let me look based on these results on other similar things or more searches I can issue. So yeah, to be a useful search model, it has to be very good at this multi-hop kind of tasks. Yeah.
Got it. And is there a reference to a time hop also? Because a different kind of similar kind of conversation can happen on multiple days, let's say, right? Some other team member asking about a good place to visit for food. So do you look across time also in that manner?
I guess that just depends on your data, right? Like if your data if your corpus of data you're searching over has like, many, I guess, is spread over time, then yeah, it would just like, it would be blind to it. But yeah, I hope that answers your question. I'm not sure.
But that helps. Thank you.
All right, we have still time for one more question. If anyone has a question, this row has been exceptional in their questions. We have one more there, yeah.
Hi, Itai. Thank you for this presentation.
Anytime.
I'm gonna ask a question, and I always ask like very pinpointy questions, but I actually think that this is actually pretty cool. And I'd seen your colleague's video a while back. I don't know if on LinkedIn or somewhere, and it looked pretty interesting. So I'm glad I got to see it.
Oh, you mean the YouTube videos?
Yeah, the one that was on the screen earlier.
Okay.
So my question is, I've worked on like some retrieval systems before, right? And there's always like an issue with the fidelity of like when you're letting the agent kind of decide what it retrieves, and like retrieving something verbatim versus like paraphrasing, and kind of, you know, kind of like there's a loss there sometimes, right? And you're also talking about the discernment that the agent kind of has in how it's able to retrieve again. Maybe they're two different questions, but how do you, is that something that you faced when you guys were developing this, the sort of like fidelity of retrieval from the agent? And how did you kind of like engineer the sort of like discernment for you guys like be able to be happy now that it's like, you know, there's the way that this agent does this work, we're ready to like release it. Was there a lot of work there, a lot of like engineering work there? And what sort of traces does it leave if the agent decides to like leave something out, right? Or discard something, so that I could check, oh, it discarded this, maybe I didn't want it to, but it leaves a trace that I could follow.
Well, yeah, if you're asking about the training process, then yeah, there was a lot of work that went into basically reading the reasoning traces of, you know, models as they do these search tasks, and, you know, using that to label what were like good behaviors or bad behaviors, or like understand how to make the system better. I think maybe to answer your first question about sort of like, you know, retrieval in general, this is why like this is the way we think about it, right? Like the way to solve searching in an AI system is actually to also use AI, right? So to delegate the task of finding the right information to an AI model that is very, very good at doing exactly that. And then with the results that process gives you, then yeah, you can then do whatever you want.
Thank you. I know that was a long question on my end too. Appreciate it. Kind of messed it.
All right. Thank you, guys.